All right, so picture this, right? Your fridge orders groceries when you're running low, or your car just like navigates that crazy rush hour traffic all by itself while you just chill.
Sounds pretty amazing.
Definitely. Like something straight out of a sci-fi movie, right?
Yeah, it's that promise of AI-powered smart devices finally becoming a reality.
It is. But behind all that seamless tech, there's a whole lot of complexity going on.
Oh, absolutely.
So today we're diving deep into this world, taking apart Lean and Agile for AI-IoT projects.
A fantastic guide, by the way.
Oh, it's packed with insights, and not just from anyone. We're talking about companies like, the big names, DeepMind, Fair.
Real industry leaders.
Yeah, uncovering their secrets to making these super intricate projects actually work.
Exactly. We're going to break down the core strategies they use, the best practices, all that good stuff. Think of it as a cheat sheet to understanding how to manage these complex projects.
Yeah, because let's be honest, building a smart toaster is one thing. But when you scale that up, imagine a whole smart factory.
Oh, the complexity explodes.
It's like checkers versus, 3D chess with robots or something.
A very accurate analogy, and that's precisely why this guide really hammers on the importance of blending those lean and agile methodologies, specifically Scrum, for AI-IoT projects.
Okay, I get that Agile helps teams break projects down and adapt to all those inevitable changes that pop up. But the lean aspect,
right?
I'm curious how that fits into making these AI-IoT projects a success.
So lean is all about doing more with less, right? Maximizing value, minimizing waste. Imagine streamlining your whole process.
Okay, so like from resource allocation to making those big decisions.
Exactly. And the guide stresses that by incorporating those lean principles, you're not just saving money, you're also getting those AI-IoT products to market faster and without sacrificing quality, which is huge.
So it's about speed, efficiency, but also making sure every single step, every resource is actually pushing the project forward.
Yeah, that's the core idea. And especially when you're dealing with those tight timelines and constant evolution in the AI-IoT world, things change so fast.
Okay, that makes a lot of sense. So we've established that this combo is like the secret sauce. But let's get into those hurdles, the things that make these projects so different from just, regular software development.
Right, the unique challenges.
First one that comes to mind, I'm guessing that whole hardware and software integration dance?
You got it. It's not just lines of code anymore. We're dealing with physical devices, sensors, actuators, all with real-world limitations. And the guide really highlights how crucial it is for those hardware and software teams to be in sync, working together. They emphasize tools like version control and CI/CD. Continuous integration, continuous delivery.
Okay, so basically making sure the brains and the body of your device are always on the same page, communicating, adapting together.
Exactly. And speaking of the real world, that's another big one, real world constraints. It's easy to get caught up in the code, but these devices have to function out there in the wild. We've got battery life, weather, even hackers to worry about.
So it's not just about designing a brilliant smart device. It has to survive the rain and not get hijacked by some cyber criminal, right?
Yeah, those are real threats. And the guide really pushes the idea of factoring these constraints in from day one. Thorough testing, robust security, making sure your hardware can literally and figuratively take the heat.
Okay, so you've got the integration hurdle, the real-world challenge, but there's got to be some upside, right? These devices generate tons of data. We can use that, can't we?
Absolutely. Data is the heart of AI-IoT. These devices are constantly feeding back valuable information.
So how do we make that data work for us?
Well, the guide talks about setting up efficient data pipelines, having checks to make sure the data is accurate, and using visualization tools to make sense of it all. It's about turning raw data into actionable intel.
So it's not just about collecting data, it's about making it useful, helping us make those devices even smarter, like constantly learning and evolving.
You nailed it. That data-driven approach is what unlocks the true potential of AI-IoT. Refining algorithms, personalizing experiences, even predicting maintenance needs before they become problems.
Okay, so we've tackled integration, real-world constraints, and the power of data. Any other big challenges lurking out there in the AI-IoT jungle?
Two more big ones the guide really stresses: continuous deployment and security. Absolutely crucial when everything's connected and constantly evolving.
Okay, let's break those down. Continuous deployment first.
Yeah.
Why is that so important for these projects specifically?
Imagine this, right? You've built an amazing smart thermostat, sold thousands of units, then boom, a software bug pops up. In a traditional model, you'd have to manually update each thermostat.
Oh, that sounds like a nightmare.
A logistical nightmare, exactly. But continuous deployment, it automates all that, ensures those devices are always running the latest, greatest software, minimal hassle for everyone.
Okay, so it's like self-updating, like magic, keeping those devices running smoothly and without annoying the user.
Exactly. Which brings us to security, maybe the most important factor in this interconnected world. We're talking about protecting data, preventing attacks, making sure the whole system is stable.
Yeah, it's not just about data theft anymore, right? Think about a malfunctioning self-driving car or a medical device. The stakes are so much higher.
Exactly. Those are real concerns. And the guide makes it clear. Robust security can't be an afterthought. Encryption for data in transit, strict access controls, and regular audits to find and fix vulnerabilities.
Okay, so we've laid the groundwork with Lean and Agile, tackled those big challenges, integration, real-world stuff, data, continuous deployment, security. Where do we go from here in our AI-IoT journey?
Now we look at the development life cycle itself, how it's different in the world of IoT, and how a framework like Scrum can be adapted to meet those differences.
All right, let's see how these principles actually translate into building those AI-powered devices.
Let's dive in. Welcome back to our AI-IoT deep dive.
So we've explored those unique challenges of developing these products and how powerful that Lean-Agile combo can be. But how do we actually know if we're doing it right? How do you measure success in this crazy complex world?
It's a great question, and the guide really digs into that. It's not like traditional software development where you just look at, lines of code or if the thing even compiles. We need to consider how the hardware's performing, the software, are we hitting our deadlines, and of course the overall quality.
So it's a much bigger picture than just does the software work. It's about the whole ecosystem of that product, how it lives in the real world.
Exactly. And that's why the guide stresses those key performance indicators, or KPIs. Setting them early on is crucial.
KPIs. Okay, so like a health check for your project, making sure everything's running smoothly.
Precisely. They give you that measurable way to track your progress, spot those potential problems before they blow up. But with so much going on in AI-IoT...
Right, where do you even start? How do you pick the right KPIs to focus on?
It starts with your project goals, right? And the unique quirks of your product. But we can break it down into a few key areas. Let's look at hardware performance, software, schedule, and of course, quality.
All right, makes sense. Let's start with hardware. What kind of KPIs are we tracking there?
Well, we're looking at power consumption, right?
Yeah,
we want those devices to be efficient. Processing speed, how fast can it handle all that data? Sensor accuracy, that's crucial, especially in things that need precise measurements. And then just overall robustness. Can the hardware handle the environment it'll be in?
So for our smart thermostat example,
Right.
we'd want to make sure the battery doesn't die after a week. It's actually reading the temperature correctly, and it doesn't melt if someone installs it above a hot stove.
Precisely. Now, on the software side, you've got response time. We want things to happen quickly when the user gives a command or the environment changes. Throughput, how much data can the software handle at once? Resource utilization, how efficiently is it using the available power, memory, all that. And then minimizing errors and crashes, that's always a good thing.
So no lagging, no freezing, no spinning wheel of death. Got it. Now what about those schedule KPIs? How do we make sure we're actually delivering on time, not slipping into those dreaded delays?
Schedule is all about staying on track. Time to market, how long does it take to go from idea to launch? Sprint velocity, how much work the team's getting done each sprint? Cycle times, how long are specific tasks taking, all those things.
It sounds like we need a whole dashboard to keep track of all these metrics. Like, are we ahead, behind, on track, all that?
It's a lot to juggle. And then finally, but definitely not least, those quality metrics, making sure that the product actually works, it's reliable, secure, and provides a good user experience.
Okay, quality. That's got to be a big one. Let's break those metrics down. What are we looking for specifically?
Well, first, does it actually do what it's supposed to do, right? Functional correctness. Then reliability. How often does it break down? How long to fix it when it does? We want those smart devices to be dependable and not require rocket scientists to troubleshoot when something goes wrong.
Makes sense. Nobody wants a smart refrigerator that's constantly on the fritz.
Exactly. And as we've already talked about, security is paramount. Assessing those vulnerabilities, doing penetration testing to simulate real attacks, making sure it meets all the security standards out there.
We definitely don't want our smart devices turning into backdoors for hackers. What about the user experience, though? That's harder to measure, right?
It is, but it's crucial. We use usability testing, observe how real people interact with the device, satisfaction surveys to see how they feel about it. The goal is to create something intuitive, enjoyable to use, that solves the problem it was designed to solve.
Okay, so we've got a whole toolbox of KPIs to track all these different aspects. But it sounds like choosing the right ones for the specific project is key.
Absolutely. You tailor your approach. The KPIs for, say, a smart home security system, those are going to be different from the KPIs for a network of agricultural sensors.
So it's not one size fits all. It's about focusing on the metrics that matter most for your particular product and what you're trying to achieve.
Exactly. Now that we've got a handle on how to measure success, let's crank up the complexity a bit. Let's talk about AI-powered IoT products.
All right, bring on the AI. Let's see how we take those smart devices to the next level.
As you might imagine, adding AI into the mix brings a whole new set of challenges. It's like going from building a house to designing a whole self-sustaining ecosystem.
Okay, that's a great analogy. It's not just about connecting devices anymore. Now they can learn, adapt, make decisions on their own.
Exactly. And to manage that added complexity, the guide lays out a 7-stage process, specifically for AI-powered IoT development.
Okay, I'm ready. Walk me through those stages. Where do we even begin?
It all starts, as it often does, with an idea. Stage 1, ideation and concept development.
So brainstorming, coming up with that brilliant spark that's going to change the world with its AI awesomeness.
That's the spirit. But it's not just about a cool idea, it's about validating it. What problem are you solving? Is there a market for this? What makes your product unique?
So making sure your brilliant idea actually has a purpose and people who will want to use it.
Exactly. Once you have that solid concept, we move on to stage 2, requirements gathering and analysis.
Okay, so this is where we get down to the specifics. Defining exactly what the product will do, how it's going to function, all the nitty-gritty details.
Precisely. Everything from the types of sensors, the connectivity, the data processing, user interface design. But with AI, there's an extra layer. You have to define those AI integration needs early on.
What does that look like? Are we talking about choosing specific AI algorithms or something?
It's about figuring out which AI capabilities you'll need. What algorithms, what models will be most effective. Machine learning, deep learning, something else entirely. You also need to consider the data you'll use to train those models, the computing power they'll need, how quickly they need to respond.
So, like designing the brain of your smart device, making sure it has the right tools and knowledge to learn and make those smart decisions.
That's a great way to put it. Once those requirements are nailed down, we move to stage 3, design and prototyping. Now things start taking shape.
Okay, so we're going from abstract ideas to something more tangible. Blueprints, physical prototypes, all that.
Exactly. On the hardware side, you're designing those physical components. Sensors, actuators, the microcontroller, everything the device needs to function in the real world. You're thinking about power efficiency, size, durability, how easy it'll be to manufacture.
So going from sketches on a napkin to actually building the first physical version of our smart device.
Precisely. And on the software side, you're developing the architecture, writing the code for the firmware, the cloud backend, any mobile apps. And of course, training and refining those AI models with the data you've collected.
And this stage, I imagine, involves a lot of back and forth, right?
Yeah.
Building, testing, getting feedback, refining, until you have a prototype that actually meets those requirements.
That iterative process is crucial, making sure you're building something that works, that people want to use.
All right, so we've gone from idea to requirements to prototype. What's next on our AI-powered adventure?
Stage 4 is where things get real, development and integration. We take those prototypes and build the final hardware and software. Integrate those AI models and test. Make sure everything works together seamlessly.
So like going from a hand-built model to a full-blown factory production line.
Yep.
Scaling things up.
Exactly. And testing is crucial here. Unit testing, integration testing, system testing. Leave no stone unturned. Catch those bugs before they cause problems out in the wild.
Yeah, a bug in a smartphone app is one thing. A bug in a self-driving car or a medical device, that's a whole different story.
Absolutely. Thorough testing is essential for safety and reliability, especially as these devices get more sophisticated.
Okay, so we've built it, tested it thoroughly. What's next? Do we just launch it and hope for the best?
Not quite. Stage 5 is deployment and pilot testing. We're not going straight to millions of users. We do a controlled rollout, maybe a small group of early adopters or in a specific environment. Get real-world data, real feedback.
So like a soft launch. See how it performs in its natural habitat before the big premiere.
Exactly. And it's not just about observing how people use it. You're gathering data to refine those AI models even further.
So the AI is still learning and improving even after the product is out there. That's pretty cool.
That's right. The goal is to create something that gets smarter over time.
Okay, so we've piloted, gathered feedback, refine the AI. What's next?
Stage 6 is where things get exciting: commercialization and scaling, taking our AI-powered baby to the masses.
Time to introduce it to the world.
Exactly. Ramping up manufacturing, setting up distribution, marketing, building a whole business around this thing.
Sounds like a whirlwind of activity, but also pretty rewarding. But even after launch, the work doesn't stop, does it?
You're right. Which brings us to stage 7. Maintenance and updates. You have to keep an eye on how the product's performing, release updates, retrain those AI models, stay on top of any issues that pop up.
So ongoing care for our AI-powered baby, making sure it stays healthy, happy, continues to learn and grow.
I like that analogy. This stage is often overlooked, but it's vital for long-term success.
Wow, we've covered a lot. From that initial spark of an idea all the way to ongoing maintenance, the AI-powered IoT journey is quite a ride.
It is. And keep in mind, this is just a high-level overview. Each stage has its own complexities, and the specific approach will vary depending on what you're building.
Right, it's not a one-size-fits-all process.
Exactly. To see how it all plays out in the real world, let's move on to some of those inspiring case studies the guide highlights.
I'm all ears. Let's see how these principles actually translated into success stories. Okay, those case studies you mentioned, I'm ready. I love hearing how these ideas actually work in the real world.
All right, well, one that really stood out in the guide is from a smart manufacturing company.
Okay, so they're using AI to, make the factory smarter?
Exactly. They wanted to boost efficiency, cut down on waste, all that good stuff, improve their bottom line.
Makes sense.
Yeah.
So how'd they do it?
They put sensors everywhere, all over the factory, gathering data on, well, everything you can imagine. Machine performance, how much energy they were using, even the temperature and humidity.
So like a constant stream of information about how the whole factory's running.
Right. But then the question is, what do you do with all that data?
Right. It's not useful unless you can actually make sense of it.
That's where the AI comes in. They used machine learning to analyze all that data, find patterns, and predict potential problems.
So instead of waiting for a machine to break down, they can see it coming and fix it before it even happens.
Exactly. Like a sixth sense for the factory. For example, the AI could pick up on tiny changes in a machine's vibrations, the kind of thing a human would never notice.
And that tells them what? That the machine's about to fail.
Exactly. They can schedule maintenance, minimize downtime, keep those machines running longer. Huge cost savings.
That's amazing. But the guide mentioned they did even more than that, right?
Oh, yeah. It wasn't just about preventing breakdowns. They used that data to optimize the whole process. Found bottlenecks, streamlined workflows, even reduced their energy consumption overall.
So using data and AI to fine-tune every aspect of the operation, like squeezing every bit of efficiency out of the factory.
Exactly. And the results were impressive. 40% faster time to market for new products.
Wow. That's huge.
Yeah.
So they can get their innovations out there faster, stay ahead of the competition.
Right. And remember that technical debt we talked about? They slashed it by 65%.
Seriously, that's a lot of time and resources freed up.
Exactly. No more constantly fixing old problems. They can focus on the future.
And I bet that led to smoother production overall, right? Fewer things going wrong.
Absolutely. They cut production incidents by 72%. Fewer delays, disruptions, everything runs more predictably.
This is a great example, I think, of how powerful that data-driven approach can be. You can transform a whole industry, make it more efficient, sustainable, more profitable.
It really shows what's possible when you use those lean agile principles, combine human expertise with AI and IoT.
So as we wrap up our deep dive here, what are those key takeaways you want listeners to walk away with?
I think the biggest one is understanding how powerful that combination of lean and agile can be. It gives you a framework to manage all that complexity, work together better, build successful products.
Right, but we also can't forget those unique challenges of AI, IoT. It's not the same as traditional software development.
Absolutely. We talked about that integration of hardware and software, those real-world constraints, using data to continuously improve, and of course, continuous deployment, strong security. Those can't be afterthoughts.
Yeah, they're essential. As these devices get smarter, more connected, we have to build them securely, make sure we can update them easily.
For sure. And one last thought for our listeners. Think about the bigger picture. As AI IoT gets more powerful, we have to think about the ethics, make sure we're using these technologies responsibly for the benefit of everyone.
That's a really important point. It's not just about building cool gadgets. It's about shaping the future, making sure this technology makes life better, makes the world a better place.
Well said. I hope this deep dive has inspired some folks out there. Maybe someone listening will build the next big AI-powered thing that changes the world.
That's a great way to end it. Thanks for joining us for this deep dive into Lean and Agile for AI-IoT projects. We'll catch you next time for another exploration of all the cool stuff happening in the world of